Here are the answers for Lesson 9-1, Day 1. First of all, some questions from the oral section. Number 1, is the ordered pair 5, 3 a solution of the system that contains these two linear equations? The first equation is 2x minus y is equal to 7. The second equation is x plus y is equal to 2. For the ordered pair to be a solution to the system means it must solve both equations. Solving only one of the equations is not sufficient. It has to work in both equations. So let's use the same technique that we did in Chapter 8 to test if an ordered pair solves an equation. In place of x, substitute 5. In place of y, substitute 3. Put the symbol equals with a question mark on it and figure out if it does equal 7. This is 10 minus 3, which does equal 7. It's yes for the first equation, but not necessarily for the system. Now in the second equation, substitute 5 for x, substitute 3 for y, put the symbol equals question mark, and then a 2. Does 5 plus 3 equal 2? No. Because the ordered pair does not solve both equations, it does not solve the system. Number 4, there is a drawing in the book of two lines. There's a grid, and there's a blue line and a red line. And the blue line and the red line intersect at a dot on the grid. The solution to that system is that point of intersection. For problem 4, the lines intersect at 2, -1. For number 5, the lines intersect at left 4, up 5. And problem 6, the two lines intersect left 1, down 3. Now questions from the written exercises. The directions for each are to solve each system using graphing method. It specifies graphing method. We have to graph the two linear equations, and then looking at the graph, we'll decide what the solution to the system is. There's 3 possibilities that can happen when you graph two lines on the same grid. One is the lines are parallel. That means they're not going to cross each other anywhere. Any solution to one of the equations will not be a solution to the other equation because there's no points of intersection. A second possibility is the two lines may intersect, like those 3 problems in the oral exercises. To find the solution, you write down the point of intersection. A third possibility is the lines are coincident. What that means is one line runs directly over top of the other line for its entire length. When you get all done drawing both lines, it's only going to look like one line because they completely overlap. Therefore, any solutions to the first equation are also solutions to the second equation. Number 1, here is a system with 2 equations. We're going to graph them both on the grid, and then looking at the graph, decide on the solution. The first equation is in slope-intercept form if you assume there's a 1 in front of the x and there's a plus 0 on the end. It goes through the origin, so here's a dot at the origin, and the slope is up 1 over 1. Draw a line through those dots. Make sure you're using a ruler to get it perfect. If you want to find where two lines cross each other, I'm sure it makes sense to you. You have to draw it perfectly, or the spot where they cross will not be in the correct location. Now the second equation. It's sort of in slope-intercept form. We need to put the negative x first and then put the positive 6. And remember that it's really negative 1x. So the slope is negative 1 and the y-intercept is positive 6. Here's a dot on the y-axis at 6. A slope of -1 means down 1 over 1, down 1 over 1, down 1 over 1, and draw the line through. Make sure that you use a ruler so you're drawing perfectly through the corners of the squares. Now the solution to the system is the point of intersection. We can see that it's this spot right here, which I just colored in blue, and we need to give that ordered pair, 3, 3. Three, 3 is the only pair of numbers that you can put in for x and y, and it will work in the first equation and in the second equation. Now number 3. The first equation is in slope-intercept form. Remember that it's -1x. So it crosses the y-axis at 2, and the slope is -1. Down 1, right 1, down 1, right 1, down 1, right 1. And accurately draw the line. Now the second equation is also in slope-intercept form. The slope is 2, or you can think of it as 2 over 1 if that helps you do your rise and run. And the y-intercept is 5. So it crosses the y-axis at 5, and the slope is up 2 over 1, up 2 over 1. For greater accuracy, we can go down 2, left 1, down 2, left 1. Those additional dots will help us cross the purple line in the correct location. The solution to the system is the intersection of the first and second lines. I colored it in blue, and it is -1, 3. Now number 5. The first equation is not in slope-intercept form. So what we can do is change it to slope-intercept form. Subtract x from both sides. Then divide all terms by -1 to change -y into +y. Now we have slope-intercept form. Remember that in front of your x, you see that m is equal to 1, or 1 over 1 if that helps you figure out rise and run. And on the end, the b is -6. So it crosses the y-axis at -6. Here's the purple dot. The pattern is up 1 over 1, up 1 over 1, up 1 over 1. As you continue this, you'll cross the x-axis at 6 and accurately draw the line. Now the second equation, it's not in slope-intercept form either. So let's rearrange it. Subtract 2x from both sides, getting y equals -2x. Now it's slope-intercept form. The m is the -2, or you can think of it as -2 over 1, and the y-intercept is 0. So the first dot goes at the origin, and the slope pattern is down 2 over 1, down 2 over 1, down 2 over 1, and draw the line. The solution is the point of intersection, which I've colored in blue. And now write the ordered pair. It looks like it's 2 on the x-axis, -4 on the y-axis. 2, -4. Number 7. The first equation is not in slope-intercept form. So the first thing we should do is change it to slope-intercept form. Subtract the 3x. Then divide by -9. This makes -3 divided by -9, which is 1/3. The slope is 1/3, the y-intercept is 0. Here's a dot at 0, and a slope of 1/3 is up 1, right 3, up 1, right 3, up 1, right 3. You can go down 1, left 3, down 1, left 3, and those dots will also be in the same straight line. The second equation is not in slope-intercept form either, so let's rearrange it. First step, add the x to move the x over to the right side. Now divide by 3. This is 1 divided by 3 with an x by it, minus 1. The y-intercept is -1. Here's -1 on the y-axis. And the slope is up 1 over 3, up 1 over 3, up 1 over 3. You can go down 1, left 3, down 1, left 3. Look what happens when you draw the red line. Now it looks crooked on the screen because I don't have a ruler, but you're supposed to be using a ruler. These are parallel lines. Parallel lines do not intersect. So that means there's no solution to the system. Any ordered pairs which are solutions to the purple line will not be solutions to the red line. Now number 9. The first equation is in slope-intercept form. This is the m, this is the b. So the first dot is at 1. And the slope is up 1 over 2, up 1 over 2. Notice as I draw this, I'm being very careful to go through the correct corners of the grid squares. Now, the second equation is not in slope-intercept form, so let's rearrange it. Subtract 4x from both sides. Now divide by -8. -4 divided by -8 is positive 1/2. -8 divided by -8 is positive 1. The y-intercept is at positive 1. I'm going to put a red dot right on top of where there was a purple dot. And the slope is up 1 over 2, up 1 over 2. As I draw the red line in, look what happens. The red line is completely coinciding with the purple line. Every answer to the first equation is also an answer to the second equation. So to write down our answer, we'll say like many solutions. This doesn't mean that every single ordered pair in the world is a solution. This means that every solution to the one equation is also a solution to the other. Number 11. The first equation is not in slope-intercept form. So let's rearrange it by adding the 2x to move it to the right side of the equals. The y-intercept is at -5. Here's the dot. And the slope is up 2 over 1, up 2 over 1, up 2 over 1, and so on. Now the second equation. Rearrange that one as well by adding the x over to the right side. The y-intercept is at -3, and the slope is positive 1, meaning up 1 over 1, up 1 over 1, up 1 over 1, and so on. Here's the line. Are the two lines parallel? Are the two lines coincident? Or do the two lines intersect each other at a dot? Yup, they intersect right here, which I colored in blue. The blue dot is at 2, -1.